Hi, today's video involves finding the average value of a function over some closed interval. And it is an extension of how we normally find the average. Normally, find the average of a certain set of numbers, a finite set. We add those numbers together and divide by the number of values that we have. Well, a function, we are considering an infinite number of sets, an infinite number of values in general. And so this becomes a little bit more difficult and requires us to use calculus, and specifically the integral. So I'm not going to go through the derivation of, but the average value of a function f of x over closed interval a, b, if f is continuous on that closed interval, is the average value, which I'm going to a dot b dot, is equal to 1 over b minus a, the integral from a to b of f of x dx. It's a rather simple, basic formula, and the derivation of it is actually pretty basic, pretty easy. You can read about it, or you should read about it. We're just going to use it right now, and I'm going to do a couple of examples. Suppose I have f of x is equal to x plus 6 over x squared plus 12 on the interval from 0 to 2. Okay, we have a continuous function over that interval. We can find the average value. As I mentioned, the average value is going to be 1/2, 1 over 2 minus 0, the integral from 0 to 2 of x plus 6 over x squared plus 12 dx. And so we're back to integration. The antiderivative of this is 1/2 x squared, and hopefully you remember what the antiderivative of 1 over x squared plus 12, the 6 will just stay. This is 6 over the square root of 12, arctan of x over the square root of 12. And this is evaluated from 0 to 2. So let me simplify this a little bit before I actually find the value. This becomes 1/4 x squared plus 3 over the square root of 12. The square root of 12 is 2 square roots of 3. So it becomes 3 over 2 square roots of 3. I'm going to leave it like that. Arctan of x over 2 square roots of 3. And again, evaluated from 0 to 2. That gives me 1/4 times 4 is 1, plus 3 over 2 square roots of 3. The arctan of 1 over the square root of 3. I'll let you think about that for a moment. Minus, when I put in 0, this is 0. Arctan of 0 is 0. Okay? What was the arctan of 1 over the square root of 3? Hopefully you recognize that, or put in your calculator as pi over 6. And so ultimately then we get as a value 1 plus this pi over 4 square roots of 3. That would be my average value. And you can get a decimal approximation of that, put it in a calculator, etc. I'll let you check that out. My second example, let's suppose that I have f of x is equal to 4 to the natural log of x all over x, and the interval that I want is 1 to e squared. So my average value is going to be 1 over e squared minus 1, the integral from 1 to e squared of 4 to the ln of x over x dx. This integral we need to use substitution on. And so this just stays. If I let u be ln of x, du is 1 over x dx. The integral part of it, the integrand, becomes 4 to the u du. However, make sure you change the limits. Don't put those limits in there that we have. We have to change those. X equal 1 means u equals 0. Natural log of 1 is 0. X equals e squared means u equals 2. So this is just the integral from 0 to 2 of 4 to the u. And so we get 1 over e squared minus 1 times 1 over the natural log of 4 times 4 to the u, evaluated from 0 to 2, which is 1 over e squared minus 1 times, I'll leave that out front, and, well, actually, let me leave times 1 over ln of 4 out front, and then we're left with 16 minus 1, or then 15 over e squared minus 1 times the natural log of 4. And again, generally I would imagine you put in this into a calculator and get a numerical approximation for that. For me, it's just easier to leave it like that.